Hello everyone, in this video I'd like to introduce how can we use Siemens PLC and FM IOLink master to write the parameter for binary tower light, this IOLink device. In the previous video I introduced how can we use the library provided from binary to control the stack light. And to control the stack light, we need to identify the control mode inside this IOLink device. So the control mode inside this binary tower light, it has 4 modes: basic segment mode, advanced mode, run mode, and level mode. So we can use the parameter 0, 1, 2, 3. We can control the segment mode for this tower light IOLink device. Then the question is, how can we use the PLC to write the parameter to this IOLink device? This video is continuous video. Please refer the previous video talking about how can we import the library provided from binary tower light. And this video, we will continuously introduce how can we use the function block to write the parameter to this IOLink device. Alright, now let's turn to the parameter reading or writing section. And the sample program also came from this library. And now we will switch gear to this document, parameter data function block. This is TL50 Pro parameter data function block. Again, parameter reading and writing usually is a little bit complex than the process data. Process data we can directly write into the queue, so we can operate the indicators. Parameter read or write, we have to use the data record, the acyclic communication. It also came from 2 sections. So the section 1 is introducing this binary IOLink master. Okay, again, most of cases maybe you are now using the binary master, then you will scroll down and find out this section at the page 8. So it's talking about TL50 Pro, this stack light with other IOLink master. Okay, again, if we are using IOLink master from other brands, so behind is actually also using Siemens IOLink device function block. There are 2 key function block we will use. One is this binary TL50 Pro IOLink. It comes from here, okay? Come from this area. And second one, it is binary IOLink control, okay? IOLink control. It is preparing something. So basically the idea is binary IOLink control, this function block is doing the circulation. And then the real task to do the acyclic communication, it is actually this. It's this. So they need to work together to implement this feature. Okay, so let's demonstrate. Okay, let's go offline, and then we will work on this parameter read and write. Then from the right side, this global library, and the library here, we import this version 14 library already here. But if you recall, binary also provide one updated library, named IOLink version 16. This one provide one updated parameter reading and writing function. So I would prefer using this version 16 one because it comes with a new version of the IOLink underscore device. The IOLink underscore device comes from Siemens one. Okay, let me also import this one into the library area. So we can open. Let me find this IOLink version 16. Select this compressed library and select this. Open, and the system will ask me where I need to deploy. So same directory here. So this is the one I did before. Then now select this library. Deploy to here and upgrade. I'm using version 18. It will upgrade from 16 to 18. Binary IOLink parameter from 16 to 18. So if we open this one, and we will see this is the IOLink binary control. It only comes with this. But if we open here, we will see it comes with this Siemens provided IOLink underscore device. To make this system work, we will copy the part type, okay, to this PLC date type. And since under this folder, it has been a lot of date type here, I will create another folder under this, so date type, under this date type. So let's call that binary tower light. Okay, parameter part type. And then I'll copy this one, paste this one, this two date type, and also copy this one to here. Okay, then we can copy this IOLink control to here. Okay, and meanwhile, other than this control, we also need to go back to the original folder, go under this Pro, and we will also need this, the Pro IOLink, this one. Okay, we will drag to here. Okay, so we need both this FB. And if we go to this FB1 first, this named control, we will see it is calling all those date type. I haven't compiled yet. It's most important role for the parameter read and write because this FB inside is calling this Siemens function block. Okay, it's calling this. And other than that, it also have some date type here. And the entire network, it doesn't have too many network, but it did call this Siemens provided this IOLink device here. Okay, how can we call this? Because default, the TI portal doesn't have this. We will also copy the function block. So let's go to this version 16 and also drag this one to the folder, this parameter folder. Okay, we will move everything to here. So move everything to here. We will see IOLink device. This is actually provided from Siemens. Siemens also has the latest one, maybe. You can also copy the Siemens latest library to this one, cover this IP, this IOLink underscore device. Then you can go to support.industry.siemens.com and find this ID number 82981502. This IOLink library, and if you scroll down and you will find this library, okay, version 18 or later, this IOLink, this library. Okay, Siemens may keep updating this library, so in case you need some new features or if you try to follow up some glitches solved, then you can find the latest library and then import into here. Okay, in this case, I'm temporarily using the one provided from Biner here. So we will compile, then all those faults will be solved automatically. Again, this control plays most important role, but why Biner supply this feature? So IP20, in my case IP20, and this named this pro underscore IOL. So if we close all the network, we will see it has a lot of program and it has a different index number. So what the role behind is, Biner did a great job providing this function block, allows us to not have to trigger the individual parameters. So it's doing the cyclic communication inside using this FB. Once we configure everything and download, I will demonstrate how easily we can change the parameter, because at the time, we do not need to worry about which parameter numbers, index number we need to write anymore. We just care parameter name we need to read or write. Then this function block will convert the name into the index number. Okay, so it's doing very smart way. Now, let's compile. Okay, no faults, no errors. That means once compile, system automatically fixes this. And then once we come back to OB1, we will call this to function block. Okay, so when we call this, it's a little bit complicated. So when we call this, we need to be careful one thing. So if we scroll down and find this area, we'll create 1 dB. But when it's talking about this area, we need to identify which port from the IOLink master we are using. This is the final style of this Biner control style. So it has a CAP, it has the ID number, it has this dB need to attach on it. This is the one typical IOLink device parameter read or write that function block style. Okay, so let's follow this instruction, and from this parameter, this folder here, let's create 1 dB. So select the dB. Okay, I will create this dB. This dB means we will operate the parameter by using this dB. Biner underscore IO LM. Okay, then for the name TL50 Pro IOLink port 2 parameter. Okay, parameter, rename to this. Okay, now let's call this most important FB, this FB1. So let's drag here, and we will give a prefix name IDB here for this binary control. Okay, so and I will drag this instant DB under this folder. So okay, all right, this DB, it has cap number. So the cap number, if we come back to here, this documents, and this document explained for the cap number depends on which IOLink master you are using. So for IFM, it's actually the B400 hex number. Since this cap in their function block is using the integer, so we'll use 46080. If you are using the Beloff, you can use 255. If you are using Siemens CM, the IOLink this, you can use 227. Okay, so in my case, I'm using IFM AL11. Okay, so I will write 46080. 46080 is actually the cap number B400. Okay, and the control ID is also another tricky here. Regarding the control ID, I will set it true if I'm using the master from IFM other brands, so it can set a false. Since I'm using IFM, so I will set it true. Okay, for this control ID here, true. TRUE. Okay, set it true. I'm using IFM AL1102, so PROFINET PN module. Okay, and this command, we will drag this DB we just created, this one, float it, and then drag this variable. So if we expand this area, we will see it has a lot of parameter here. So we will drag to here. Okay, and the communication arrow, so we can set one bool, we can receive this result. So in this case, it's not quite important, so we will leave this empty here. And here's one important thing. So from this DB here behind, we will see this port controlled and the port active. So we need to tell the system which port from the master is connecting with IOLink device, this binary device. In this case, I'm using the port 2. So I need to set this port 2. So that means before I call this function block, I need to create a new network, and I will set this port 2 to on to tell the system, hey, I'm using the port 2. Okay, the port 2 we will set to true. We'll set true to this port 2. So I will write here binary AL1102. Okay, port 2. Okay, we set the parameter, and then this function block will start using this DB. Okay, then we will call the other one, the function block. This one is converting the DB setting to the index number, the parameter index number. So we will call this to here, and we will set this IDB binary, this one. Okay, and we will also drag this one to this folder. Look at this. This function block also try to ask us which port we are using from the master. So we are using the port 2 from the master. So we will select the port 2. Okay. Then what does it mean of this? So we will see this function block also need to use this DB. Meanwhile, it's enabled, we can use this active signal. If we slide away, and we will see, so it's enabled, it will use this port 2 active number 2. Okay, so this function block will collaborate together. That's why it's in and out here. Once the active 2 is active, the port is active and is matching with this port number, so it's operating this DB. We'll also drag this one to here. Okay, and we haven't fully finished yet. Last step, according to the menu, it's just talking about this ID number here. If you remember, when we are talking about the uncyclic communication, we need to assign the hardware ID to the uncyclic communication IFB. So where we can find this hardware ID? This is actually hidden somewhere. It's hidden behind this IFB. Okay, so now if we open this instant DB, and this is Siemens function block, and the Siemens function block, this hardware ID, we need to set this value. And this function block prepared this hardware ID list. And this hardware list, it is located at here, this ID array here. Okay, it's very hidden, it's not quite great. So if for the new user, they will maybe ignore these things. So that's why I like to demonstrate this. Now let's float it, this instant DB. So the alternative way is we will use moo. We will use moo to control this instant DB. It's not quite ideal. Ideally, those ID number should be one of the input parameter we can set. So this is the alternative way. Again, since we are using the port 2, okay, we are using the port 2 from the master, so I need to set this ID array 2, give a number, the ID number. The ID number comes from the hardware configuration. So if we jump to and go to this IOLink master, and from this second port device, if we go to the properties, and we will see the system constant, and we will see the binary tower light, this second port is hardware identifier, this value is 279. So that ID number need to set 279. And we can go to the PLC tag, and this PLC tag go to the system constant, float it. Okay, and we can go back to the program here. We can scroll down and find 279. It's a unique number, and 279 is exactly represent this hardware ID, this binary tower 32 outputs. So we will drag this one to here, and this 279 will set to this array 2, this is port 2, and this is instant DB inside here, okay, and it will write the parameter. Okay, this active 2 will be used for the control enable command, and the port 2 will also need to set here. Okay, so now we can download the program and we can try the parameter. We go online. So this cap number set true, and we will see it doesn't have a arrow. So, and we will see this active is being toggling. Okay, we can see it's toggling. And now, according to the manual here, to control the parameter is actually controlling the instant DB of this IOLink instant DB here. So now, if we open this instant DB, if we open it, and we click online, from this TL50 Pro data, read data and write data, they are here. Okay, we will see the read data. This is actually keep updating this data, because every time the active is triggering is reading the parameter, and we can see the vendor ID 451 and the device ID, the 393.219 is reading here. Okay, and the series number also read, and the version numbers. Okay, and the write data, we will see the system command operating mode here. So number 1 means the system default is advanced mode, and also from this value we can control the mode. Okay, and now let's verify the current mode inside this IOLink device. Okay, we are using this manual, this IFM engineering tool, and we can monitor this current active operating mode from this binary tower, this mode. And now it is advanced mode. It is number 1. Okay, number 1. Okay, now let's back to the PLC area. And if I'm going to control this mode to operating mode 2, so I will write directly to this 2. Be careful, this one is an instant dB. So from this binary solution, we have to directly operate this instant dB. Okay, this instant dB, it is this IOL instant dB behind. Okay, we set a 2 here, then we can verify which kind of mode from the IOLink device. Okay, and then we'll scroll down, and we can see, so operating mode now has been changed to the run mode. It is number 2. Okay, run mode, it is number 2. So, okay, we can change to the basic mode. Let's go back. And this time, I can set to 0. Okay, we set to 0. You do not have to trigger any command because the system, this function block, plays a role for the triggering by itself. Okay, so now we set operating mode to 0. Okay, let's scroll down. So we can see the operating mode now is changed to the basic mode. Basic mode is 0. So using this way, this function block, we can control this mode. And now we can leave this operating mode 0 and this basic mode. And now if we go back to the process here, the process data, to match this basic mode, we will change to 0 and then we will control the light. Let's see the performance. Okay, now I'm going to go offline, and currently inside now is a basic mode. I will change to 0, basic mode, to match this. And still segment 2. Okay, I have 2 indicators. And this time, let's download. Okay, now it is basic mode. Let's verify if we can use basic mode to control it. So now if I'm opening this DB, go to the definition. If I'm active this DB, process data. So since now it is basic mode, so we will try to control the command at here. And if I'm directly operating this DB data, so now the audio state, let's try it again, audio state. So command the audio state, so we can, 0 means off, 1 means on. Okay, so I'm going to change this on. Okay, we will see the audio turn on. If I set to 2, it's controllable. That means now the basic mode is active, and we will use this basic mode to here control this DB inside, and we will use the mode 0 to control this tower light. Now set to 0. Okay, now the second one. So this time the second one, we are now able to control the light because now the light color is defined inside the parameter. So now if I switch to the parameter list, I switch to here, we will see under the basic mode, the second one is set green color. Okay, green color. And the segment 2 we set to red. So this color has been defined. Under the basic mode, we are using the parameter list to control the light color. But now using the basic mode, segment 1 is green and segment 2 is red. So let's go back to the program. So now segment 1, if I'm going to control it on, okay, we will see segment 1 is green, it is on. And segment 2 is red. I will control it to flash. So double click, flash. Okay, so we will see the color defined behind, and we can use the basic mode, the process data directly control it. Okay. Now, if you're in case by using the basic mode, you have to control the light. So let's go back to this Pro IOL, this instant DB behind DB4, and the right data here, the segment, the basic mode parameter, we'll see the basic color, the segment 1, the basic color is green. Back to the parameter list, the green here, if I open this, 0 means green. If I intend to change to blue, so it will be the 9. let's change the segment 1 to blue by using the parameter function. Okay, so back to the program here, the basic color, if I set to 9, we will see it immediately change to the blue color. Okay, so if I switch to 0 back, it will change back to the green. So even though we are under the basic mode, but we're still able to use this function block to change the parameter by using this write data area. Okay, again, this dB is dB4, and it is the instant dB of this area. Okay, and the communication important function is playing the role at here, but when you're operating the parameter, we are using the instant dB here. It's not quite ideal operating the instant dB, but this is the way binary supplied. This is the way we can change the parameter. And by using this way, we do not care the parameter list and the parameter index number. We just go browse this instant dB, and from this list, we can change the parameter. Okay, this is the binary TL50 Pro, this tower light or stack light. The parameter reading and writing, we demonstrate how can we use this two function block to implement this parameter reading and write. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.